coming of the Second Republic has instigated the implementation of projects which are of paramount importance to the development of Zimbabwe, and some of these projects include Chirundu Harare Masvingo Bait Bridge Road construction, Gwai Shangani Dam construction, new Parliament building in Mount Upton, Bait Bridge border expansion, Mbudzi interchange, and Wange Power Station expansion. These and other projects will assist to fulfill the attainment of an upper middle income economy by 2030. Moving with the theme, Reinvent and Industrialize for Economic Development, the government through the Ministry of Higher and Tertiary Education, Innovation, Science and Technology Development pushed forward the operations of Verify Engineering to construct a strategic business unit operating as VE Gases plant at Feruka in Mutare.
It had initially been established in 2005, but with the coming in of the new dispensation, Verify Engineering has been given a new mandate to support the new Education 5.0 philosophy, in which our education system is going to be guided by the philosophy of teaching, research, community service, industrialization and innovation.
In Zimbabwe, medical oxygen was the most critical component as it was seriously needed. Thus, many countries throughout the whole world had to find ways of producing their own oxygen for medical use to combat the ravaging effects of the coronavirus. Our team visited Verify Engineering Gases plant in Mutare to assess the progress made so far by the largest medical and industrial gas producer in the country since its launch in August 2021 by His Excellency President Emmerson Dambudzo Mnangagwa.
We designed this plant to produce 30 tons of gaseous oxygen, 16.5 tons of liquid oxygen, and we also produce liquid nitrogen. As of last year, during the launch, we were producing around 2.5 tons per day of liquid nitrogen, but we have since upgraded it to around 7.5 tons per day of liquid nitrogen. We have 3 identical plants which operate in tandem. They operate 365 days at least 75% availability. We produce medical grade, 99.5% purity oxygen. The plants are segregated. We have a plant that is dedicated for industrial oxygen, and we have a plant that is dedicated for medical oxygen, and we have been certified by the Medicines Controls Authority of Zimbabwe.
We were responsible for setting out of this plant, and all the civil works, we did them, and then we did the installations. After the installations, we then went on to do the commissioning of the plant. This plant, the air separation unit, it has got 3 units which are similar. So I will go through one unit which comprises of 2 compressors, which are the source of our air. We are drawing the air from the atmosphere. That is our main raw material. Then this air, when we draw it with our compressors, we compress it to about 60 bars. Then when it is at 60 bars, we pass it through skid vessels, which would be purifying our air. We remove the carbon dioxide, we remove the moisture, which is always present in the air, and we also remove the oil, because our compressors are piston type, which use oil to lubricate the pistons. Then after removing those impurities, we are only left with nitrogen and oxygen. This nitrogen and oxygen, we then pass it through what we call a distillation column. In the distillation column, the air will separate into 2 components. 65% of it will go into the expansion engine. Then the 35% will go into our expansion valve, which acts on the Thomson principle. After that, these 2 components will later mix when they are now in liquid form. And in liquid form, we use the difference in the boiling point of nitrogen and oxygen to now separate the two components. Nitrogen will go up to the top column, while the oxygen goes to the bottom column as a liquid. When we want to get liquid oxygen, we then use our batch tanks, which have a capacity of 5 tons. The batch tanks will then transfer the liquid into our main storage tank, which is a 120-ton capacity. As I am speaking now, we have got about 100 tons of liquid oxygen in our main storage tank, which means we are only short of about 20 tons to fill it to capacity. Basically, we are now doing what we call campaign filling, because we've got different customers who want liquid oxygen, others want gaseous oxygen, medical and industrial.
We are into research and development, as you are aware. Therefore, there are quite a number of different engineering departments that are there in order to be able to install a factory or an industry that produces a product. Like what we are producing here is waste gas. In this case, we are talking about the oxygen production unit, which you are seeing here.
As part of the fabrication team leader, we were the ones who joined all this steel that you are seeing behind me. So what we do is the process guys, they tell us their designs and what they want to be made. And what do? We go to our workshop and we play around with steel and come up with the plant like what you are seeing that's behind me. And you can see the plant is running right now. So what we do is we also run the maintenance of the plant day to day. So whenever there's a breakdown, it's also my duty to make sure that we rectify that breakdown in time so that the plant is available and it's up and running every time.
My task is to measure and control process variables within the plant. These include pressure, temperature, level, flow, and purity. This is achieved by the use of instruments like pressure gauges, temperature sensors, level indicators, flow meters, and online analyzers. Calibrations are done periodically to make sure the instruments are functioning very well and they are reliable at all times.
Verify Engineering has another strategic business unit operating as VE Energy, which moves with the theme Total Power Solutions for Sustainable Development. This unit is currently constructing a 3-megawatt solar power plant at Feruka, with 100,000 watts already supplementing power requirements at the same plant.
Our core mandate as VE Energy is to generate power from renewable energy sources and non-renewable energy sources. So here at Feruka, we've got a 3-megawatt solar power plant, but we have this phase of 100 kilowatt, which we are now feeding into the ZESA grid through a net metering.
The plant itself runs with a voltage value of 415 volts. After having reduced the voltage from 6.6 kV, which is our main supply from ZESA. We also came up with the designs for routing of the cables in the plant. Trenching is part and parcel of that, and we had to include civils production for that trenching of our cables. We also had to design positioning of our plant to supply the power to the machinery, which is our main drives to the plant.
This unit has other solar projects underway in Shangani and other 4 state universities in the country. Under its research and development unit, VE Energy is currently developing its own lithium-ion battery, starting with material synthesis, cathode development, and culminating in battery assembly.
As VE Energy, we are working on the design of a 50 megawatt solar power plant to be located in Shanghai and to be grid connected at 132 kV into the ZESA grid. We have also designed a 600 megawatt thermal power station for a site in Mukwasini. For 6 sites, we've designed 18 megawatts solar power plant. Zimbabwe is a rich country in terms of solar irradiation. We've got an irradiation of an average of 5.7 kilowatt hour per square meter per day of energy. So we are harnessing that energy to backfeed into the ZESA grid. Our substation got a capacity of 2 MVA. So we are scaling up this solar power plant to 3 megawatt, whereby we will feed all this whole complex with the 2 megawatts, and then the excess power of 1 megawatt will be selling it into the ZESA grid. So we've got an array of solar panels which are harvesting solar energy, and then through the inverters, we invert the DC power from the solar arrays, then feeding into the ZESA grid. From the solar field, we are now in the control room. The purpose of this control room is now to control the generation from the solar arrays in the field, and then to grid connect, and then to backfeed that power into the ZESA grid. So here we've got the PV combiner box, and then we've got the inverter. So we've got different arrays in the solar farm. So we integrate all the power from the solar arrays in this PV combiner box. Then from the PV combiner box, we then invert that DC power into AC power, so that will be usable in the ZESA grid. So we invert from DC to AC using this inverter. This is a 20 kilowatt inverter. So in this control room for our 100 kilowatt, at the moment we've got 5 by 20 kilowatt to make it 100 kilowatts. So we are upgrading this power plant to 3 megawatt. So as VE Energy, we've got the capacity to design, to construct, to commission, to operate, and to maintain the power plants of whatever size or feeding power onto the ZESA grid.
This laboratory, we are carrying out a research program as part of our waste management and recycling process. In our ASU plant, we have got a lot of waste oils which are used in our compressors. So these waste oils tend to lose viscosity with time as they are used in the compressors. So in this laboratory, we are carrying out a research program where we are restoring those waste oils, which we call oil recovery, to bring it back to its natural state. Instead of dumping oils or wasting into the environment, we are carrying a research into environmental management of the waste oils. In that process, we take those waste oils and we react them with acids, and then we utilize coal, which we have in our lab, and we make activated carbon from coal. Then we react our oils with activated carbon to extract impurities, which will be in our oil. And after the extraction process of these impurities, we further upgrade our oils up to the purity and the quality of the original oils. This process will present cost-cutting measures for our company, because instead of buying new oils every time, we are able to utilize the oils which would have been utilized in our plant, which as they have gained the viscosity. In this laboratory, we also carry out quality assurance tests on chemicals, cleaning chemicals, which are used in our ASU plant. We are manufacturing medical oxygen, so the cleaning chemicals which are used for cleaning our plant as well as cleaning the cylinders are tested in this laboratory to ensure that they do not contain toxic materials. So we test them and we certify them in the laboratory before the dispatch of our medical oxygen to the market.
Efforts are being implemented to make sure that spare parts for the machines set at VE Gas's plant are produced locally at the same plant.
For the efficient running and productivity of our air separation plant, we need spares. We are building capacity to produce our own spares here. We are establishing a machine shop where we are going to be producing our own spares. We already have machines which we have procured, which are going to be part of the machine shop. The rest of the machines are coming in. This is all done with the strict observance of our standard operating procedures, safety, and quality.
This is done to make sure that there is continuity of operations, as the spare parts will be readily available whenever need arises.
We have got various multi-skilled team. As you might have noted all along, we've got capacity to produce electricity through the solar power systems. So that covers one area of electricity. We can maintain the electricity. We've got experienced manpower in that area. We've got capacity to do fabrication work, to do mechanical work. So it means all the maintenance work, we can do it internally without having to outsource. And this saves a lot. It saves us a lot in terms of finances. We also have a design capacity, which means if we want to produce any new product, we can start it from conceptual stage to design it, manufacture it and fabricate it and produce a final product. So what I'm trying to say is we've got internal capacity as Verify Engineering to do all technical work from civil works, mechanical works, electrical works, process and design, chemical works and things like that.
Safety, health, environment and quality are totally adhered to in all Verify Engineering projects and processes. Hence, they adopted the name SHEC Total, meaning that all these precautionary measures are meticulously considered and followed.
As SHEC officer, my responsibility is to audit, to advise and to assist. As an organization, our motto is SHEC Total. Everything that we are doing, we are incorporating SHEC issues, first priority. Meaning when the engineers are doing their designs, we need to review them to check if safety issues, health issues, environmental issues and quality issues are incorporated in our designs.
What we do is that during production, we have online analyzers that give us the purity of the product. But then my job is to cross-check that product, that purity of the product. Like for example, oxygen, we have to cross-check it to see if it meets the required standard. At the laboratory, we have two methods that we use to cross-check. We have the OSAT analysis, that is a chemical method, and we have a digital portable analyzer.
In 2005, this project, an EIA was done for it. EIA stands for Environmental Impact Assessment, to check the impacts of our project to the environment and to the social environment. So that was done as part of SHEC Total. And also as an organization, because we want to produce quality goods, we value our customers, we're in the process of implementing a quality management system, which is ISO 9001 of 2015. This quality management system ensures that in all our processes we are including the SHEC Total.
To make sure the products produced by Verify Engineering are of world-class standards, a continuous monitoring and evaluation process is done from the product inception until it is ready for distribution.
As M&E department, we are there to track the projects from project initiation to project completion. When we are tracking, we are looking at the resources and the timeliness of completion of the projects. The purpose of this completion and timeliness is for us to achieve our objectives as Verify Engineering and to also play a part in the national objectives stated in the NDS1. So Verify Engineering looks at industrialization and innovation. The purpose of this is for us also to play a part in the issue of sustainability. Verify Engineering also is guided by the SDG goal number 9, industrialization.
To make sure that everything at Verify Engineering is properly done, legal issues are at the core of operations.
The issue of governance of public entities is actually a constitutional requirement. So as a company, we have an obligation to comply with the provisions of the Constitution of our country. We are also obliged to hold annual general meetings. We are obliged to file, annual reports with the relevant offices. We strive to do all that, and we are happy that according to the Corporate Governance Unit last assessment, we scored a mark of 67%. So that rating of 67%, naturally motivated us, and our desire now is to score as high as 100%.
In terms of product distribution, VE Gases has now the capacity to cover the whole country, with filling stations being set up across all the 10 provinces. These filling stations will be supplying both oxygen and nitrogen gases.
The job of VE Gases is to actually market and distribute these products, beautiful products, throughout the country. And we have the necessary infrastructure to carry out that distribution. As you can see, we've got a large number of cylinders of different sizes to serve the health sector and industry at large. We also have road tankers, which we have to distribute liquid oxygen, again, throughout the country. We also have distribution infrastructure for liquid nitrogen. We also have flasks for distribution liquid nitrogen to our customers who use liquid nitrogen. We also have cylinders for distribution gaseous nitrogen. To crown it all, as VE Gases, we are going to put up infrastructure throughout the country to make it easier for the market to access our products. A game changer which we have put in place is filling stations throughout the country at strategic locations. What these filling stations entail is that we will not be carrying, for example, cylinders from this station to Bulawayo, for example. What we are going to do is we will distribute the gas, liquid oxygen through our road tanker and then decant at our filling station in Bulawayo. What it then entails is that our catchment area in Bulawayo can simply then bring their cylinders to the filling station where they can access the oxygen. We have served big and small entrepreneurs. As you know, gases are used in hospitals, gases are used in mining, gases are used in other large companies who have got plants of various nature, and we have been able to distribute those gases to those places.
And in that regard, we are now penetrating the regional market. We are now registering our products with COMESA and the PTA, as well as SADC, in order for us to be able to supply countries. And this is riding on the existing bilateral agreements and international treaties and organizations of these organizations I've just mentioned. And of particular interest as well is that we are going to be supplying 25 tons of liquid oxygen to Botswana, which was donated by His Excellency, Comrade Dr. Mnangagwa. And we are certain that with that we'll follow up again and continue to supply more gas in Botswana. In Mozambique, we have also secured the market in Mozambique after the donation of 150 tons of medical oxygen by His Excellency, Comrade Dr. Mnangagwa. And in Mozambique, we are going to be installing 3 tanks of 20 tons each and 1 tank of 15 tons each, which are going to be installed in hospitals in Beira, Chimoyo, and Tete. And that is going to allow us now to be supplying oxygen into the Mozambican market beyond the donation that was made by His Excellency.
This milestone has been achieved within a short space of time due to the existence of a dedicated workforce with a focused and goal-oriented leadership. As the president always says, Nyika inovakwa neve nevayo. This is indeed what is being spearheaded by Verify Engineering Private Limited.
The last 2 years, I should say, were very successful in the history of Verify Engineering. We managed to support, we managed to commission and a plant, oxygen producing plant, and also we managed to commission a solar plant. And all this success was as a result of the immense support which we got from our government. And for that, we remain grateful to our President, His Excellency, the President, Comrade E.D. Mnangagwa, and also our Minister of the Ministry of Higher and Tertiary Education, Innovation, Science and Technology Development, Professor Dr. Amon Morwira, Permanent Secretary as well. I want to mention that these people have actually helped verify to achieve what we achieved for the last 2 years. Without the staff at Verify Engineering, we wouldn't have done much. They went out their way, working tirelessly, 24 hours in many instances, to not going to see their families, but their sweat has actually then produced all these results which we are now talking about.
In recognition of the work done at Verify Engineering, several awards have been given to the organization, among them the Gold Medal Award winner at the 2022 Zimbabwe International Trade Fair.
For all that work which we have done, we have received accolades. The world is starting to notice what we are doing at Verify Engineering. For example, Verify recently received the Megaface Business Awards, Eastern Region Awards for 2021 as the most dynamic and versatile organization of the year. The platinum winner. We were the platinum winner. We were #1 in the country in the Eastern Region Awards, Dynamic and Versatile Organization of the Year. When we went to ZITF this year, we also managed to win in the energy category, #1 as the best exhibitor in the energy, the Zera Energy Award. This one was the Zera Energy Award, which we win, and this one was the medal, the gold medal.